This video is sponsored by DFRobot. Hello YouTube and welcome to Heathen Hacks. Well, look at you. You finally did it. You managed to reach the last project on the starter kit. Congratulations! Glad to see you back. I assume that you've just finished project number 14. If so, let's move on to project number 15 or IR-controlled LED matrix. And, just like on the previous video, we're going to do our warm-up project or two before the main one. I think it's a good practice to check and see if the components would work individually first before we merge them together. That way, we'd have no doubt that all the components are working properly, and it would be easier for us to fix potential problems because we just have to look at our code and connections and not think about if the modules or components are broken. But before we continue, I'd like to update you guys on some stuff first. As you may have probably noticed, or not, this last batch of 5 videos from the series took a really long time to be uploaded. And when I say long, I mean a long time. It took like what? Almost more than 4 months? Damn! For context, as you can see here, I shot the series of videos for this batch last March 16, and by March 31, I've already finished Project 14's script. But you may be wondering why the video sequences on Project 15 are not titled yet and why is there no script present? Well, truth be told, I've already finished the script for Project 15. I think I was able to finish it late last June. I was just waiting for the right day to do the voiceovers because there was some construction stuff going on. Then, while I was playing around on my fresh install of a Linux distro, I accidentally nuked my NVMe SSD where my Steam library, Adobe Suite, all my Blender files like assets, HDRIs, finished and work in progress 3D render projects that are supposed to be included on this batch of videos, and upcoming videos for the channel are all stored. I lost a total of about more than half a terabyte of data. That happened when I tried to change the file system of my NVMe SSD from MBR to GPT. My monkey brain took over and selected yes without even reading. It's like I had a momentary tunnel vision. On the bright side, I back up my stuff every month. The bad news is, I only back up my stuff every month and I don't back up everything. Just a few that I deem to be important, or else my backup drives would fill up really quick. Ironically enough, I was supposed to back up my stuff when that happened. I lost it instead of keeping it safe. To add insult to injury, the last backup I have of this specific directory was last April. Yeah, I'm still asking myself why I did not include it during my backup last May. And to add more salt to the wound, my Samsung 860 EVO SSD where my Windows 10 OS died out of nowhere. It just did. One day I just couldn't log in and I kept on having errors. I don't know. Well, all I can do now is to live with it, learn from my mistake and move on. So, here I am. Apologies for the long intro, I just think that it would be a good PSA to remind you guys to back up your stuff regularly. Alright, now back to the video. Let's go! Here are the things that we're going to need for the warm-up project. The DFRduino board, prototyping shield, male-to-male jumper cables, 220 ohm resistors, and lastly, the 8-segment LED matrix. Now that we have our things prepared, let's move on to the wiring phase. Let's get our DFRduino board, mount the prototyping shield on top of it, mount the LED matrix right about here. Remember that the decimal point is on this side, alright? Connecting this correctly is important. Now let's add the resistors. We're going to need a total of 8 resistors for this. You can just follow along with me here, okay? This wiring diagram is also available on the PDF, by the way. Let's start with segment B. Segment B is located right here. Segment DP right here, segment E right here, and segment G right here. Followed by segment F, segment A, segment C, and segment D. Make sure that there are these blank pins at the middle because that's going to be used for power. Now let's connect the resistors to their designated pins. First, let's connect segment B to DFRduino's digital pin number 2. Segment A is connected to digital pin number 3, segment F to digital pin number 4, segment G to digital pin number 5, segment E to digital pin number 6, segment D to digital pin number 7, segment C to digital pin number 8, then segment DP to digital pin number 9. After that, connect the pins that we left blank to 5 volts. This one right here, then this one right here. And we're done with the wiring part. Alright, let's connect our board to the computer. Here's the sample code that DFRobot has provided. Let's just copy and paste it from the PDF since the sample code's pack doesn't include the warm-up project code. Make sure that the MCU is being detected and we're on the correct port. Click on verify, then upload the code. As you can see, looks like we've messed some things up. By the looks of it, it seems like numbers 3, 5, and 9 were in this array. So on number 3, instead of segment D being lit up, it lit up segment E. On number 5, same as what happened to number 3, instead of segment D being lit up, it lit up segment E. And on number 9, segment D was not lit up. We clearly have some fixing to do. Now, we know that the problem is not because of the sample code.
Correction. This part on the code to display number 9 is wrong. This should be 0.
We know that our module is working properly, so that only leaves us with the connection being wrong. After double checking the connections by comparing it to the PDF, I have determined that I've mixed up pin 6 where the segment D is connected and pin 7 where segment E is attached. Alright, let's check it again. And there we have it. A bit weird that segment D is still not lining up when number 9 is being displayed though, but no biggie. So here's how the long version of the code works. We didn't need to declare anything globally here, so we headed straight to the void setup. Inside void setup, we have a familiar looking block of code. We use the for loop here to set pins number 2 to 9 as output using pin mode and use digital write to set their initial output as high. And since we're using a common cathode LED module, all of the segments would be turned off on the first instance. Moving on to the void loop, here we have the long part of the code.
Not to be confused with the long data type, okay?
So basically, to display each number to the LED module, we have to use an array. An array is a collection of variables that are accessed with an index number. Int n08 equals 0001 0001. On this line of code, we add an int type array, name it n0, and assign 8 values to initialize it. When declaring an array of type, one more element than your initialization is required to hold the required null character. Taking a look at our cheat sheet, referring to the array initialization, the fourth element of the array is at index 3 or n03. And its value is 1, and the 8th element of the array is at index 7 or n07 and its value is 1. By the way, the 8 inside the square brackets is the number of elements. After initializing the array, here we have another for loop. This is to assign high or low values to pins 2 to 9 of the DFRduino board by using the pin variable and digital write. Pins 2 to 9 is actually where each segment of the LED module is connected. The pin variable on digital write changes in conjunction with the pin variable on the for loop every time it's incremented. So for example, when the initialized value of pin is equal to 2, n0 pin minus 2 becomes n0 0 because the variable pin, which is 2 minus 2, is equal to 0, which points to the first element of the array with the value of 0 or low, which then makes segment B that is connected to digital pin number 2 to be turned on because we're using a common cathode LED module. When the variable pin from the for loop gets incremented to 3, segment A would be turned on, and when the for loop increments it again, segment F would also be turned on, and so on. On int variable n0, segments B, A, F, and EDC have 0 or low values, so they are turned on, and segments G and DP are turned off because of the values 0001, 0001. Each value represents the high or low values of the segments which are controlled by the digital pins. If you want to output letter A, we'd have to light up segments B, A, F, G, E, C, and the element values should be 00000101. That's basically how it's done. I think the cheat sheet I made pretty much eases the process of understanding it. Feel free to copy or improve it if you want. So we've seen the demo of the long code. Now here's the demo of the short code. It just displays or does the same thing, but it uses the shorter version of the code. Here's how the short version of the code works. On the first sketch, we manipulated 10 arrays, each with 8 elements corresponding to values in the segment from B to DP. On this sketch, we will manipulate 10 one-dimensional arrays to form a two-dimensional array. Think of it like putting a bunch of chocolate monkey heads inside some acrylic boxes and then putting those boxes inside a bigger acrylic box. The monkey heads are the elements, the acrylic boxes are the one-dimensional arrays, and the bigger box is the two-dimensional array. So at the very beginning of the code, we add an int variable called number. This is to store the values or elements for each number. These two numbers right here represents the number of arrays, which is 10, to display the numbers 0 to 9, and the number of elements in each array, which is 8, which are pin numbers 2 to 9. Just below the number variable, we have a function called numberShow with an int variable called I and a for loop inside it. It actually works in conjunction with the for loop inside the void loop. But before we continue on to that route, let's move on to the void setup first. Onto the void setup, we have another for loop. And just like on the first iteration of the code, it's to set up the segments or pins as an output by using pin mode, and to set the pin's initial value as high by using digital write. Now, let's talk about the correlation between the numberShow function outside of the void loop and the for loop inside it. Void numberShow int I. Here we have a function called numberShow which is accompanied by an int variable called I, where the value of variable I would change in conjunction with the value of variable j inside the void loop. Then we have digital write pin number I pin -2. This is the one that combines the results from the for loop inside the void loop and the pin or segment number and the number variable to get the array number and element number that would control the on and off state of the segments or pins.
Okay, but how does it work exactly though?
My brain cannot do it.
Well, it's a bit tricky to explain, but I'll try my best, alright? So first, let's start with the main program, which is the void loop. Inside the void loop, we have this for loop. The initial value of j is 0, and the initial value of pin is 2. The value of the pin came from the numberShow variable. The for loop inside the void loop would then be this. Now, since we already have the value of variable j, variable I on the numberShow function would also change to 0. And that would change digital write to digital write pin number 0 pin -2, or digital write to number 0 0, because the initialized value of pin is 2 and 2 minus 2 is 0. From there, it would then become digital write to 0 because the element on the first array's value is equal to 0. Digital write to 0 would then light up digital pin number 2 or segment B because 0 or low is equal to high when using a common cathode LED, and because segment B is connected to digital pin number 2. After lighting up segment B, the numberShow function would continue the loop going from pin equals 3 to pin equals 9 very fast to display number 0 for about 500 milliseconds, after which variable j would be incremented from 0 to 1. Change the value of variable I from 0 to 1 and then the cycle would continue. That's pretty much it for how the short version of the code works. Now let's move on to the main project. Okay, this time we're going to need two more components. The IR remote control, of course, and an IR receiver. Let's connect the IR receiver right here. Remember that the flat side should be at the back. Connect the right leg to 5 volts, middle leg to ground, and lastly the left leg to DFRduino's digital pin number 11. Alrighty then, let's plug in our board to the computer. Here's the sample code that DFRobot has provided. It's quite long, isn't it? Make sure that the MCU is being detected and we're on the correct port. Click on verify, then upload the code. And since we have the serial print line of code present, let's launch the serial monitor as well. And then make sure that it's on both NL and CR. Okay, let's see if it's working. Click on 0. Hold on, let me just turn off this light. Let's press push button 1. As you can see here, it's visible on the serial monitor too. Let's press push button 2, 3, 4, 5, 6, 7, 8, 9, 0. Hey, very nice. And yep, that's it for the code demo. So here's how the final code works. Just a heads up though, I forgot to include how the numbers increase and decrease in value when the backward and forward buttons of the IR remote control are pressed on the final code video. So I made a simple Blender animation for it. Okay, first we include the IR remote library. Add the variable receive pin to the IR receiver which is connected to DFRduino's digital pin number 11. Add the IR receive data type from the IR remote library and make it use the receive pin variable to set it as dedicated IR receiver port or pin. This line of code uses the decode results data type from the IR remote library and saves what the IR receiver is reading or receiving by using the results variable. Int current number equals 0. Add the variable current number for, well, current number storage. After that, we have a data type called long, with a variable called codes and the value of 12, which are the number of hex codes inside it.
Basically, the hex codes are for numbers 0 to 9 and the forward and back buttons.
Its main job is to store the hex values for each number, because each button on the IR remote has a corresponding hex value or hex code that are saved in the library. When a button is pressed, the IR remote sends out that button's hex code. It would be received by the IR receiver, then the program would check if that certain hex code is included in the list before doing anything. If the hex code that was received was not included, nothing will happen. That's why you can't just use a single remote control to control two appliances from different manufacturers, or if the appliances have different model numbers but from the same manufacturer. For example, I can control the two fans in our house using a single remote control because they are from the same manufacturer and have the same model number. But I can't control our other fan that's from a different manufacturer using the same remote control, even if the other fan can be controlled by a remote control. Int number 10:8. This array is responsible for storing the values that would display the numbers to the LED module, followed by the void number show int I function that we just talked about earlier. On the void setup, we have the IR receive data type from the library and the enable IR in function that is from the library as well. We've actually discussed how it works on project number 14, so let's move on to the void loop. On the void loop, we have an if statement that checks if the decoded hex values from the IR remote control are received and then stored them in the variable called results. The if statement is followed by a for loop that gives an initial value to the variable called I and would be used by the codes variable. Just like what I was talking about earlier, this block of code right here verifies if the received hex codes from the IR remote control are on the list of hex codes from the codes variable, and checks if the value of the variable I is less than or equal to 9. If the value of variable I is indeed less than or equal to 9, it would call the number show function that would display the numbers 0 to 9. The value of variable I would also be used to assign a value to the variable called current number, and then print the said value to the serial monitor, followed by a control structure called break, which is used to exit from a for, while, or do while loop. Now, this is the part that I forgot to include on the final code demo. It first checks if the received hex code from the IR remote control is equal to or have a matching entry on the hex code number 10 from the codes variable, and if the currently displayed number value is not equal to 0. Then it would decrease the value of the currently displayed number by using a decrement compound structure. Display the decreased value to the LED module, print the decreased value to the serial monitor, and then exit the loop. The else if code block below does the same thing, but instead of decreasing or decrementing the value, it increases it if the received hex code is equal to hex code number 11 and if the currently displayed number value is not equal to 9, followed by serial.println results.value hex to display the received hex codes to the serial monitor, and finally, wait for the next signal or button press. Additionally, according to the PDF, there should be a corresponding executable code following every if statement. Whew! That was quite confusing, huh? Alright, let's do an example. Let's say that we press button number 6 on the IR remote control. What would happen is that it would transmit a hex code 0xFD6897 to be precise, and it would be received by the receive pin because it is set to be the dedicated IR receiver port because of the IR receive data type from the library. The received hex code from the IR remote control would then be saved to the results variable. The stored hex code, which is now on the results variable, would then be evaluated if it's included on the list of hex code inside the codes variable. And since the initial value of variable I is set to 0, the for loop would continue to loop until the hex code that is saved to the results variable matches with something. When that happens, codes I would become code 7 because the 7th hex code on the list is 0xFD6897. After finding a match, the value of variable I would be checked if it's less than or equal to 9, and since it is, the if statement would call the number show function. Then void number show int I would become void number show 7. After that, the for loop inside the number show function would start to initialize and light up the segments or pins. it would start from DFRduino's digital pin number 2, so the digital write would be digital write to number 7 2 minus 2, or digital write to number 7 0, which would then become digital write to 1 because the value of the first element on the 7th array is 1, which would turn off segment B, because if you can recall, on our cheat sheet earlier, segment B, which is connected to DFRduino's digital pin number 2, is the first element on the array. After turning off segment B, the for loop would continue on looping up to pin 9 or segment DP. So, digital write would be like this. After calling the number show function and doing what needs to be done, current number equals I would then become current number equals 7, and then the value of variable I, which is now 7, would be displayed to the serial monitor. After which, the hex code that was stored in the results variable earlier would also be displayed to the serial monitor, and then the program would wait for another signal or code, then do the process again. Well, there you go. That's pretty much it. This is the last official project of the starter kit, but stay tuned for more. I know that it can be quite confusing, so for a more in-depth explanation, please refer to the PDF. Click right here if you feel ready to move on to the next project. See ya!